Last time we discussed a type of differential equation which was solvable for P. Now we discuss next case which is solvable for Y. Let me share the screen. So second case, equation solvable for Y. So we consider differential equation f of x, y, p equal to 0. Means we consider a differential equation which is some relation between x, y and p. P is dy by dx. Suppose that this differential equation 1 can be put in the form say y equal to capital F of xp. Means we can solve 1 for y. Okay, so given differential equation 1 can be rewritten as y equal to some relation between x and p. Now, how to solve such a differential equation? So, first step is differentiate this equation 2 with respect to x. Differentiate 2 with respect to x. So what we get, we must have left hand side as dy by dx equal to differentiation of right hand side with respect to x. So in general we can write this as differentiation of capital F. Now capital F is function of x and p, where p is dy by dx, so it is function of x. So by chain rule this will be partial derivative of capital F with respect to x into derivative of x with respect to x. So it is 1 plus partial derivative of this capital F with respect to p into derivative of p with respect to x, that is dp by dx. We are writing partial derivative for capital F because it has more than one variables. But for p, we have only one variable x, so we are writing d. So this is differential equation in p. Further, left hand side is dy by dx, so it is dy by dx is p. So that is p equal to del f by del x plus del f by del p into dp by dx. So we call this as 3. This is first order differential equation in P. And of course degree is also 1. So in the first step we have to solve this differential equation. and we call solution of this equation 3 as z. So let z of, so solution of this will be function of x, p and arbitrary constants equal to 0. We call it as 4. This be solution of 3. Okay, 3 is differential equation in p in variable x. So solution will contain p, x and arbitrary constants. Now step 2 is we consider equation 4 and given differential equation or the converted form, say y equal to f of xp. So this equation 2. So these two equations contain p. So we try to eliminate p from these two equations. That means we find value of p from equation 4 and substitute into. Eliminate p from 4 and 2. That is, find p from any of these equations and substitute in other, and substitute in other equation, so that we get relation between x, y and z. The resulting relation is required solution. Okay, so this is our procedure. So what we do, first, given differential equation 1, it is a relation between x, y and p. We suppose that it can be solved for y. That means the same differential equation can be written as y equal to f of xp. In the first step, we differentiate this equation with respect to x and we write p for dy by dx and obtain a differential equation, first order, first degree differential equation in p. We solve that equation and we eliminate p from the solution of this equation and given differential equation. So resulting relation will be in x, y and arbitrary constant c, which is a required solution. In some cases, it is not possible to eliminate p. So in that case, we take this equation 4 and 2 as parametric equations in p. So given any value of p, we get value of x, y and z, relation in x, y and z. That means we can have a parametric equation in x, y and z. Parameter is p. That means we keep as it is and we just write down that equation 4 and 2 form solution of given differential equation. So second case is not if it is not possible to eliminate p, then the equation 4 together with 2 form solution of given differential equation. Let us solve examples. First example, solve xp square minus 2yp plus ax equal to 0. Remember that this equation can be solved for p also, and we can find the solution. That is also correct. So if you are asked to find solution using particular method, then you have to use that method. For example, if it is asked to solve this equation by uh, using the second case, that is solvable for y, then you have to use that method only. But if the question is just solve differential equation, then you can use any method as you wish. In some cases, one method will be simpler than the other. So it can be decided after practice. So here, to explain this theory, we solve it for y and find solution. So given differential equation can be written as, so what we do, we write this as y equal to some function of x and p. So we add 2yp on both sides and divide by 2p, so that y equal to 1/2, we are dividing by p and there is p here, so it is xp, and there is ax, so plus ax divided by p. Okay, so we call this as 1. So this is solvable for y. Now first step is differentiate this equation with respect to x. Differentiating with respect to x, we get left hand side is dy by dx, but dy by dx is p equal to 1 by 2. Now differentiation with respect to x, here we need to use product rule. So x into dp by dx plus p into dx by dx, that is 1, plus a is constant into derivative of x is 1 into, again we are using product rule. So derivative of x is 1 and 1 upon p as it is. Then ax into derivative of 1 upon p. So derivative of p raised to minus 1, it is minus p raised to minus 2. So divided by p square into dp by dx. We simplify this. So it is here on left hand side we have p, on right hand side we have 1 half p. So p minus 1 half p, it is 1 half p. So p by 2. Then there is constant a divided by p into 1 by 2. So minus a divided by 2p equal to, now terms containing dp by dx. So we have x common. So x by 2 into, it is 1 minus a upon p square into dp by dx. Now we simplify this. Left hand side is, so we write this as, we multiply and divide by p, so it is p square minus a divided by 2p equal to x divided by 2 into, this is p square minus a divided by p square into dp by dx. So we cancel common factors, p square minus a divided by 2. So it is, yeah, p can also be cancelled. So left hand side is simply 1, right hand side is x, we have cancelled divided by 2. Then it is simply x divided by p dp by dx. Now this is quite simpler equation, differential equation in p. So it is dp by p equal to dx by x. So that integration gives log of p equal to log of x plus log of c, and that means p equal to c into x. So this is solution of differential equation in p. We call it as 2. Now we eliminate p from 1 and 2. That means from 2 we have p equal to cx. We substitute in 1. So substituting in 1 we get, so in 1 we put p equal to cx. So y equal to 1 by 2 into xp plus ax by p. X can be taken common. X can be common here. So it is p plus a by p. P plus a by p. So it is cx plus a upon cx into x, or it is y equal to 1 half cx square plus a upon c. So This is the required solution. We see one more example. Example 2. Solve y equal to x plus a into tan inverse p. Remember that a is constant in this equation. In previous example also, a was constant. So given dE, so it is written as y as a function of x and p. Y equal to x plus a tan inverse p. So solvable for y. So we differentiate this equation with respect to x. Left hand side is dy by dx, that is p equal to derivative of x is 1 plus a is constant. Now derivative of tan inverse p, it is 1 upon 1 plus p square into derivative of p by chain rule. So it is dp by dx. Okay. So this is differential equation in p, which we can simplify. So it is p minus 1 then p minus 1 equal to a upon 1 plus p square dp by dx. So we try to write down in variable separable form. So it is dx equal to a divided by p minus 1 into 1 plus p square dp. This is variable separable form, and solution is obtained by integrating this. Now what is integration of the term a upon p minus 1 into 1 plus p square? A is constant here, so we use partial fractions, and here 1 upon p minus 1 into 1 plus p square. You can use partial fractions and write this as 1 by 2 into 1 upon p minus 1 minus p plus 1 divided by 1 plus p square. So we use in given equation. Okay, therefore dx equal to a by 2 into dp by p minus 1 minus p plus 1 dp by 1 plus p square, or it is equal to a by 2 into dp by p minus 1 minus, here we write as p plus 1 divided by 1 plus p square as p divided by 1 plus p square plus 1 divided by 1 plus p square. And in the denominator, if we use u equal to 1 plus p square, then du is 2p dp. So we have p into dp, so we multiply and divide by 2. It becomes 2 dp upon 2 into 1 plus p square minus dp by 1 plus p square. Now we can integrate. So integration gives left hand side integration of dx. It is simply x equal to a by 2 into, this is log p minus 1 minus 1 half into log of 1 plus p square, and this is tan inverse p. Okay, so minus tan inverse p. So we get relation between x and p, but it is quite complicated. So instead of finding value of p, we use this equation along with given differential equation and call it as solution. So we call this as 2 and write equations 1 and 2 form the solution. That's all. Thank you.